Okay, thank you very much. So it's a real pleasure to speak to you today. I unfortunately was unable last minute to make actual travel work, so I'm sorry to not be there in person, but it's my distinct pleasure to be speaking to you. I'm aware of a lot of the great work Data Science Nigeria does, and so it's a real pleasure and honor to get a chance to talk to you about some of my work today and maybe give you some sense of some of what's going on in the trustworthy machine learning, trustworthy AI world. Before I get started, I thought it would be useful to say a little bit about my background, maybe add some additional details to some of the bio on how I got where I am today. So I started off so I was born in Lagos. I went to international school, ISL in UNLAG, for my, I guess, primary, secondary school and all that. From that time, I moved to the US for university. And so at the time, I moved to New Jersey Institute of Technology. And there I was studying electrical engineering. And so I finished with a degree in electrical engineering, at the time focusing on control systems, which is where the area that I thought I spent most of my time in. Upon leaving New Jersey Institute of Technology, I went on to graduate school at the University of Texas at Austin. So there I was an electrical engineering major as well, and similarly focused initially on control systems, and then I shifted a bit to wireless communications. And then towards the end of my PhD time, I ended up landing on machine learning and AI as the area that got me most interested. And so this is what ended up finishing my PhD on. I did some core work in the field thinking about probabilistic machine learning, and then I was looking at science applications. And these science applications eventually led me to Stanford University for the first time. At the time, I was a postdoctoral candidate housed in psychology department doing a combination of work on neuroscience and AI. And at the time, actually, my office was pretty much right around here. So I had a really good view of this is the Stanford lawn that I had, I guess, at the time experienced as a postdoc. I finished about 2 years there, and then I moved on to the University of Illinois Urbana-Champaign as my first job as a faculty member. So this was in Midwest US in the computer science department. They're looking at, again, some foundational work in machine learning and AI, and then trying to apply these tools to scientific applications and increasingly healthcare. So this was around 2016 or so timeframe. Around a couple of years into my time there, I started working a little bit with Google. My first big experience was when Google opened a lab at the time, an office in Accra, Ghana, and invited a few of us to help with some of the initial bootstrapping and setting things up. So I spent some time there and then back to my primary academic job at Illinois. And eventually, I ended up spending some time in transition full-time at Google for about a year or so before moving to where I am now at Stanford University, where I work. This is the computer science building. So I work in computer science. Once again, I can see my office. I'm around there. And my group at Stanford thinks about what it means to build trustworthy AI. So our work includes thinking about what trustworthiness means. How do I define it? How do I measure trustworthiness in AI systems? How do I implement and deploy mitigations or fixes to issues with trustworthiness? And so the way that we do this is that we think through all of the aspects of building AI systems, all the way from questions of capability, so how good are the systems, to when they break, so various kinds of robustness, and increasingly various kinds of bias. So what kinds of bias and fairness issues can the algorithms, when deployed, have, and what can we do to make sure that those issues don't lead to harm in the real world. In addition to my academic work, since about 2021, I've been the board president of Black in AI. So Black in AI is an international organization with a mission to shift the power dynamic in the AI ecosystem and increase the range of voices, broaden range of voices who are contributing to the development, deployment, regulation of AI technology. And our future mission is thinking through what can we build to make sure that the field is barrier-free and anyone who wants to engage is able to engage and contribute across the global ecosystem. And so to do this, we do a variety of different different programs. Some that you may be aware of include our conference programs. Most saliently, we have a conference program at NeurIPS, which is the big ML and AI conference, where we bring people from across the world to both engage in the conference, but also present within the group some of the work that people are doing in machine learning and artificial intelligence, build community, and then from there, hopefully, sort of build expertise in our community on these topics. In addition to this, we also, I think another successful program is the Emerging Leaders in AI program. What this program does is help train people who are thinking of applying to graduate programs. So this is solve some of the resource and knowledge gaps that sometimes cause issues when applying to graduate programs. Questions like, when to apply, how to get reference letters, some of the informational bits of success in applying to graduate school that sometimes people are just not aware of because they're not exposed to the academic system. Some of the resource gaps, like, can you help cover parts of, say, application fees and things like that? So the program is specifically designed for this transition between either undergraduate or working professional to considering engaging in graduate programs in artificial intelligence. And we try to make that transition easier for people who are interested in this kind of effort. So that's that on what I was going to say about background. I want to move now to spend maybe an hour or so talking about some of the foundations of trustworthy machine learning and artificial intelligence, focusing on the version of this question in 2021, all the way starting roughly around 2021 when a lot of the excitement, I think, really peaked, all the way to now, 2024, where AI systems are now widely deployed and having increasing amounts of impact in the world. So I don't need to, I think it's probably not that useful, but maybe going through, lots of examples that we now have of AI systems that do what would have been thought as impossible or extremely difficult things. I'm showing here Copilot, which is no longer even state-of-the-art in this task of synthesizing code completions. So if you're writing software, helping you sort of complete software. So, this was exciting when it first came out. Since then, there have been lots of new tools from lots of different places that have even pushed this even further in terms of the ability to automatically write code. There's increasingly also, again, this is old, but just to give some examples of being able to synthesize images. And so you can add increasing amounts of context or detail and sort of the style, pencil drawing versus photos, and still get, I think, quite incredible results in many settings. So again, we found, just, I think, incredible applications of AI to lots of knowledge tests that, again, would have been thought of as impossible only a few years ago. All this said, the core technology is often fairly straightforward, and then the key is sort of scaling these things up to sort of really large scale. So, for instance, in language models, as many of you know, the core technology under the hood that makes this work is word completion. So this idea that I give a machine learning AI model a lot of different examples of what text looks like. But the observation is if I give this examples of text. And when I give it examples, what I ask the model to do is to fill in missing words. So, forward plans to, and then, the model should guess what might be a good next word there. Or you might imagine doing this in the middle of phrase, forward plans to something AI factory. You might imagine build as a reasonable completion of that sentence. So what happens is under the hood is, the models are asked to do these kind of word completion. But what's been found is that if you scale this process up much more than has been scaled in the recent past, so talking about trillions of examples across the web to billions and trillions of parameters in a very large neural network model, you really start to see some incredible properties of these models. So I'm showing some, in this case, even older examples of illustrations of in text, going from fairly simple tasks like language, simple kinds of language understanding, all the way to being able to complete translation work, pattern recognition, sometimes arithmetic kinds of work. So showing incredible improvements across a range of different downstream potential tasks by scaling up the way that we build models. And so this is the opportunity part. This is a lot of what has driven the excitement in the field, both internally, but also increasingly externally. This incredible observation of sort of all of the potential ways that language models seem to be able to do, or AI models in general, seem to be able to be a stand-in for being able to solve cognitive tasks of various kinds. And so the plan today is to build off some of this background, but primarily my goal is to take a step back from some of the front-end applications to think through what it might mean to make sure we build the systems in a way that we have some confidence about the trustworthiness. And so to this end, my goal will be to talk through some of the highlights of previous and ongoing work in trustworthy AI specifically, with trying to draw connections to some of the open problems and some of the exciting frontiers in some of this area of research. I'll also try to provide pointers to existing work, literature, other interesting questions for those who are interested in exploring in this kind of area. It's worth saying that, as you know, AI is a huge area with lots of different work. Increasingly, every day, people publish new papers, hundreds of thousands of new papers in the field. And so keeping up with all the details is itself a sort of almost full-time task. Even the narrow area of trustworthy AI does have, as you might imagine, a huge amount of work in it increasingly. And so I'm not planning on a complete overview, but I hope to hit the key points and highlights to hopefully shape some framing of the problem that hopefully is useful in engaging in these questions. I'll also state, I'll give some examples, but it's worth remembering that trustworthiness by construction mixes the technical part of this, which is the tools that we can build to enable trustworthiness, with societal questions. What do people mean, or what do people hear or feel when they engage with technological tools in terms of endearing trust? And so I'll touch on some of the human societal aspects to give a flavor of this intersection of work. But I'll admit now that my coverage will focus a lot more on the technical aspects of the work, leaving some of the societal questions open. And I'll highlight them as we go, with an invitation to think about these questions and maybe connect to some of the existing literature that tries to answer some of them. And then I'll also mention, also because of the nature of trust and it being so specific to human preferences, insights, values, it's clear that I won't, the conversation, the nature of the question is constantly evolving. And so I want to acknowledge the fact that some of what I say now, while accurate and sort of reasonable for October 2024, might change as the landscape of AI changes. So all that said, there are broadly two parts in the discussion today. The first part will try for motivation, why we care about trust and trustworthiness in AI systems, and then cover some of the existing points of view frameworks that engage with this question, and then touch on briefly some of the social, political, and industry landscape that both motivates and impacts broadly thinking about trust and trustworthiness in AI systems. And in the second part, I'll talk about one aspect of tooling that seems to be having some of the biggest impact in the way we think about trust and trustworthiness, which is how we think about evaluating AI models and building benchmarks now that AI systems have become much larger in scale and are doing so many more tasks than they used to in half a generation ago, not even years, a few years ago. And so I'll go through some aspects of how one builds benchmarks and some examples that exist out there, some of the perspectives that shape thinking through benchmarks, and some of the lessons we've learned as we've been developing evaluation and benchmark processes over the past few years. Okay, so as many of you know, the reincarnation of a lot of the excitement around AI are very tied to some of the observations of, or some of the deployments of chatbots in recent years. I think when they were released, I think what was striking for many people, where on one hand, this ability of the chatbots to have very human-like interactions with people. So the interface was so different. It seemed, so natural, if you like, almost human to be able to engage with these systems. But on the other hand, we found inaccuracy in many of the responses. So this is now generally called hallucination. This issue of models having various kinds of inaccurate responses. And many of these have impact. You can imagine, in fact, there are now lots of use cases, for instance, in law, where lawyers have chosen to synthesize arguments for plaintiffs using AI models, so things like ChatGPT, and will then have mistakes in their arguments that have cost either issues with various kinds of lawsuits or even disbarment for various lawyers when, for instance, they cite case law that doesn't exist. So they're making up stuff. When Google presented, at the time, I believe, Bard first, some of the early presentation, they found that there were mistakes in what the chatbot responded. In this case, I believe it was a space question. And this led to lots of loss of confidence in technology. So, real world harm, or at least a real world impact. Depending on where you stand, you may or may not call this harm, but real world impact on Google's technology, or in this case, stock price, once this mistake was shown in their demo. So again, highlighting some of where the science and technology is starting to connect with real world impacts. Lots of other instances of various kinds of potential issues with healthcare. I'm showing here some recent work arguing about potential race issues in the way AI models respond to questions, in this case, in a particular clinical use case. I'll illustrate this example a bit in more detail in a few minutes. And then, various instances of worry about privacy in many of these AI systems. So they're collecting user data, user interactions. What does this mean in terms of the ability of users to own their data, the risk of privacy leakage, the risk of other people figuring out details that they don't wish to share about their data. And so in particular, various countries for some time banned things like ChatGPT. So Italy, for instance, banned ChatGPT for some time because they were worried about the privacy implications and holes that were not closed, where, for instance, many of the interactions with the models were used as training data. And so people were worried that eventually one could steal information about individuals from interacting with chatbots and other kinds of models. Beyond this, the broad landscape around trustworthy language models, trustworthy AI, I think has continued to increase. So legal, I think, has been an interesting one. So legal and governance broadly, I think increasingly have become a big part of the conversation when we think about what it might mean to deploy AI safely. So examples that come to mind include the EU that had AI law, I think one of the earliest iterations of regulation specifically targeting generative and modern AI. the U.S. Around similar times coming up with a Bill of Rights. I'm aware of conversations on the continent, various parts of Africa, and Nigeria as well, thinking about what regulation might look like engaging with generative AI systems. And so increasingly, a part of this ecosystem are regulatory perspectives and what they consider important in terms of making sure that when these products are deployed in society, they don't lead to net harm to individuals or to societal fabric. In addition to this, there's lots of decision making that people are doing increasingly with highly capable, or at least interested in using capable language models, AI systems. And so, in addition to new regulation, there's also lots of existing regulation that immediately applies when you're making decisions about people using any kind of technology or any kind of tool. And so this includes non-discrimination laws in many countries. So ensuring that whatever decision being made doesn't systematically discriminate against certain subgroups. Privacy laws, we already talked about a little bit. So ensuring that engaging with a technological system doesn't lead to loss of privacy and unexpected mechanisms that can release individual information out into the wild. In addition to, I think, the more legal perspective, there's, of course, individual users are increasingly more aware and sometimes worried about various kinds of trustworthiness gaps in technological systems, AI systems specifically. And so examples of failures that people hear about generally have the effect of people losing trust in AI systems. So, a conversation 2 years ago was often highly optimistic, say with working professionals, about how they might use AI systems. I think people are increasingly aware that while they can be useful, they can make mistakes. And so the mistakes are often leading people to sometimes even overcorrect in terms of where they think these tools can be useful, where they can be trustworthy. I think one interesting and I think highly impactful for me as an educator aspect of this are AI systems in education, where I think educators have been grappling significantly with this question of if there is a AI system that people can get access to in a teaching setting, I'm giving homework and coding, but a student can look up the code. Now they don't need to search. They can simply ask ChatGPT, for instance, to answer a coding question. What does that mean about teaching coding? And then when it fails in various ways, what does that mean about my level of trust in the system in various kinds of deployments? So I think some of these questions are increasingly, really I could spend the whole hour engaging with some of these questions. But I think these are increasingly questions that society is trying to grapple with and have meaningful impacts on what we think about when we're considering deploying many of these modern AI systems. Increasingly, as I also mentioned, failures of privacy, failures of equity broadly, toxicity, fairness, all these issues erode user trust and have an impact on public opinion on many of these AI technologies. And so, as some of you might know, there is an entire area of study that thinks about what it means, what trust in automation means. I won't do this area justice, but I just wanted to touch on some of the literature and how sort of professionals that think about this topic with the help of maybe framing how we can think about trust and trustworthiness from a sort of formal lens. And so some of the highlights, I'm quoting a bit from one of the, I think, seminal papers in this area, engaging in this question of trust in automation and what it means to design for appropriate reliance. And the main thesis in this paper is that humans, the gap between technology and humans often is because of miscalibration in trust. So often people either overtrust a algorithmic system or automated system or undertrust. And either over or undertrust lead to issues. And really, we should be aiming for calibrated trust. So this paper goes through both thinking through what calibrated trust might mean in context, and then goes through some examples of how one might intervene to help set the right levels of trust in an automated system. And so some of the highlights, as mentioned, include thinking about the impact of trust. So trust influences the reliance in automation because people, while we think of technology as really a technical problem, when deployed in the world, people respond to technology in general socially. Another quote, trust guides reliance when complexity and unanticipated situations make complete understanding of automation impractical. And so this is anchoring on the point that increasingly we're deploying systems where we don't understand fully exactly how they work. And so when you don't understand fully the way some automated system works, we generally come up with mental models or simple framings of an approximation of what the system might do. And the way that we guide this framing of when we can rely on systems in various deployments generally comes down to a notion of trust. So we have a mental model of what a system might actually be able to do. Based on this mental model, we will generally then decide when and whether to trust systems in real deployments. And so a lot of literature tries to understand how social notions of trust in people, so how we think about trust as society, which is these questions of how people learn to trust each other and what that trust means. The thinking and research in this area suggests that trust in automation follows similar kinds of processes as trust in society. And so it tries to understand what translates from how we think about trust across people to trust between humans and technological systems. So various questions related to, for instance, what resolution are you thinking about the usage of the model? Is it a very high level general capability? Is it a specific kinds of questions that models or AI systems are useful for or not useful for? Often questions tied to, or models tied to over time. So, have the models gotten better or worse over time in your experience? And then you calibrate trust based on people's mental models of, say, what has happened to ChatGPT over the past few years for various kinds of potential applications. All these aspects end up guiding how people respond to technology and then their calibration of trust. And what I often tell people is maybe the most important thing about this maybe first section of the discussion. If there's one thing you want to remember, I think the key thing to remember is trust and trustworthiness are not the same thing. So, trust is an individual and societal feature. So this is the willingness or ability of people to decide to rely on algorithmic systems or not, depending on its capabilities and their opinion of its capabilities, which is very different from a algorithmic point of view, this question of trustworthiness, which is I think of as really what are the algorithmic mechanisms, what can we build in our AI systems such that those AI systems are worthy of individual and society trust. And so these are very different concepts. Trust is something about people's behavior and preferences. Trustworthiness is something about the technology's capabilities and technology's affordances and technology's approaches to mitigate gaps in its use. And so as mentioned before, in an ideal world, we always want calibrated trust. So trust in a system to match what the system can actually do. In practice, we often find that we end up in one or the other extreme. So either distrust, where we think systems are much worse than they actually are. I think this often happens when we, say, try a few examples tied to very specific use cases. I'm interested in a poem in, say, a particular Yoruba dialect, and the model doesn't do a good job of it. And so one might infer distrust of the system not being good at this kind of task in general, where really it's about the specific use case and inability of the model to be useful in that use case. And so this can be hard because this, for a person, it's almost extra work in, when can I rely on a model or not rely on a model? And part of the technical part of this work is making it easy for people to calibrate their trust. So what work can we do such that people don't have to do a lot of additional mental effort to get a good sense of when to trust AI systems and when not to trust them? And ideally, build systems such that they can be trusted in a very broad range of potential use cases. As mentioned, there's also overtrust, which is the other side of the coin. So this is when people think of AI systems as, or automated systems in general, but AI systems in particular, as generally capable, and then lose that, they can be imperfect in many important ways. So this shows up good examples for me in healthcare. We often see this. In law, we've seen lots of examples of this, where because many of these systems are good at general question answering, just kind of conversational question answering. People sometimes imagine that they're automatically good, say, at answering legal questions or healthcare questions. And they fail sometimes spectacularly in those settings because now there's this gap between the human overtrusting the system and then deploying it in a place where it's not appropriate. And so the societal question to answer is, how do we build towards calibrating trust so that trust is appropriate for the real use cases? But on the technical side, we want to think through what can we build in AI systems such that they end up being trustworthy, so they're appropriate in the deployment in various settings. And so this is a lot of what guides a lot of research in my group, and also lots of the space broadly is engaging this question of the technical side of this. So what can we build in our systems such that they're actually trustworthy when deployed for individuals or when deployed in society? So one acronym that I found meaningful as a sort of summary of framing of trustworthy AI is thinking about SAFE. So S being safety and security, all the way from questions of cybersecurity, so issues of infiltration, loss of privacy of various kinds, all the way to questions of robustness to real world changes in the environment. So often these are called distribution shifts, but there's a question of what happens if I deploy a system in a different setting than you trained it. What will your system do? And so making sure that systems behave or degrade gracefully when they break, or don't break if possible, when deployed in various kinds of settings. Accountability focuses on people's engagement with technology and ask questions about transparency and the role of stakeholders in building technological systems. Fairness focuses on outcomes of technology across individuals, society, and globally across different, even larger groups, all the way to questions of how AI, how we build AI and its impacts differentially across different countries, different continents, questions like that. So we ask in these settings, what does global equity look like in AI systems? Or individually or across groups, does AI models lead to systematic harm to individuals or different groups? And finally, efficacy, which is this capability question. When is the model correct? When is it capable? When is it applicable? Some of this is technical framing, so understanding and evaluating so that we can guide use cases. Some of this is improving the tool itself, so making the models more capable, more performant, more correct, and many more use cases. And so around this framing of how we can think through and build trustworthy AI systems, many of these questions show up all the way through how we build algorithmic systems more broadly. So from a technical point of view, one framing of the key steps in choosing to build an algorithmic system include first thinking about what problem you want to solve. This could go all the way from very narrow problems. I'm in a healthcare setting. I want a diagnosis system that helps me diagnose heart failure from EEG systems automatically. Or I want to diagnose potential of fetus issues during pregnancy based on measurements of the maternal health. So these are very narrow directed questions, some of which I've worked on, all the way to broad questions that you may ask in, say, modern general purpose AI systems. I want a system that is a good language model, which is a very broad framing of a problem. And so when you frame the problem, there are questions about what one actually wants and what the impact is of that technology in society. So what does it mean for policy? What does it mean for social perspectives? What does it mean in deployments? And so often they're hard questions to ask. And I think I'll confess that often for technical people in particular, don't always ask these questions before building systems. Sometimes we build first and then go back and think about what questions we should have been asking about whether we should have built a system in the first place. I think increasingly the impacts are clear, such that there is a better understanding of being much more thoughtful in problem selection before building AI systems. As all of you know through, I'm imagining through all tutorials and previous knowledge in the area, the lifeblood of machine learning and AI systems is data. So this is the source, underappreciated source that makes everything work. And so data collection often plays a huge role in the downstream way that your models end up working. And so one of the avenues that one can answer questions tied to trustworthiness is in how one chooses to collect data. So often questions of fairness, transparency, robustness can be traced back to issues in data collection. And so increasingly, that's a big focus in trying to think through trustworthiness in large AI systems, are questions of how we ensure data collection in ways that are aligned with the values that we want from the systems. In addition to problem data selection, often the next step is to think about how we measure that we've made progress in the problem that we specified. So this often ties to questions of benchmarks and evaluation processes. I'll talk through that quite a bit today. Increasingly in AI systems, there's this idea of red teaming, which is having people engage with the models before release to figure out some of the edges of the system. So where does it break that we may not have anticipated before? And sometimes this is actually very tied to very narrow questions that are technical. Questions like, what metric am I using to evaluate my AI system? And what does this metric imply for outcomes that I'm defining? And I'll go through some examples that we found where choices and metrics can have a big impact in your algorithmic system. And then usually once you have the algorithm, you have the data, and it's tied to a specific problem, then we build AI systems. And so in this building, generally, this is some kind of training process, usually using some kind of large-scale gradient descent. There's lots of opportunity to think about mitigations for trustworthiness issues, to making the system more robust, making the system more fair. We've done work, and many of you might have done, or at least engage in this question of what can we do in the development cycle and algorithmic training such that we engender better trustworthiness properties of AI systems. And finally, once you deploy your AI system, we can often ask questions of post-deployment measurements. So I audit the system in the real world, see where it's working, see where something breaks. Often I think this is an interesting dichotomy between, say, what I've seen in academic systems versus industry systems. In many industry systems, your deployment is to your customers. And so often you care a lot about customer opinion on whether your system is working for them, at least to the extent that you can measure and to the extent that it drives their, say, purchase decisions. And so often there's a lot of effort paid to monitoring systems once deployed. Academics sometimes fall into this trap of thinking of AI systems as one shot. So I just build a system, I deploy it somewhere, and I never have to look at it again. And in practice, AI systems are just not built to be that they're not built to be robust in that way. And in practice, correctly deploying an AI system generally means that we need to look at the system in context in the real world after we've deployed it. So ask questions of how do we monitor performance of the system? How do we monitor trustworthiness issues that show up in the system? How do we build in audits? And what do we do to correct issues when we find them? So often these are some of the missed issues in deploying AI systems at scale that increasingly people are paying attention to as important aspects of trustworthiness. And so I'll go through some examples to anchor this general lifecycle framing. Some of these tie to, as mentioned already, this question of data when we're building algorithmic systems. And I find this salient because the way that we think of building AI systems, but even increasingly or importantly, the way that we teach how people should think about building machine learning AI systems generally assumes that the data that you're going to evaluate your system on seems similar to the data that you trained your model on. So have you ever heard of this term IID, independent and identically distributed? This is a standard term in building AI systems. This is, again, a key assumption that your data looks the same across training, and then the data that you're deploying on looks like the data you trained the model on. Now, any of you who have ever built or deployed an AI system knows that this is generally not true. That almost always the data that you're deploying the system on will look quite different in various ways from the data you trained the system on. So this could be something simple like it's a different season of the year, and the phenomenon that you're predicting is correlated with seasons. Say you're building something tied to shopping, say a shopping prediction algorithm or a pricing prediction algorithm, and you're doing that. Clearly, there's seasonal or other kinds of like time aspects to this prediction. And if you train your model, say when it's hot, and you deploy it when it's rainy or when it's cold, it can have lots of mistakes because it hasn't accounted for this difference in where the data is coming from. And so this gap often shows up in the failures of our AI system. So, I'd argue this is actually most common or very common. It's not the exception. There's often some kind of shift between the data we train the model on and then what happens when we choose to deploy it. And increasingly, there's a understanding that the data you choose to train your model on has a big influence on what it will actually produce for you when you're done. And this has impacts, for instance, on using the internet as a source of data, because the internet is in some ways distorted as a mirror of society and individuals, because it reflects really what people choose to put on the internet and who chooses to participate. And this can be a very biased sample of society. And so some of the existing work engaging with this includes lots of work in how we build better data filters to maybe reduce the impacts of imbalanced data on individuals and society. Other examples of where data plays a role include examples and adversarial examples, as you might have seen. So if you haven't seen this, it's an interesting aspect of most algorithmic systems and honestly, increasingly human systems, but it's very salient in modern AI systems. And it's this idea that I can create examples that to humans look the same, but can fool algorithmic systems of various kinds in significant ways. So I'm showing one of the early examples on the top here, where this is at the time, some of the early work showing that I could take images of, say, a panda, and I think this was either ImageNet or CFAR, one of these large computer vision data sets. I can add noise that looks like garbage to a person. This addition creates a new image that, again, looks equivalent. So to a human, the image on the left and the image on the right look the same. But to a model, these are very different images. And it goes from a classification of panda with sort of high confidence to a completely different classification of, in this case, a given with extremely high confidence. And so this is a mistake that the model has made. And the worry that we have is that adversaries can intentionally inject data into AI systems, either at training or at prediction time, to get these kinds of errors to happen. So this is different from errors that happen because the data naturally changes, because, say, things like seasonality changes, environment changes. I'm deploying the system in a different place, literally, say, different location than I trained the system. But here I'm showing that an attacker or some third party is intentionally trying to get your system to make an incorrect decision. So the cases where this is motivated, often things like financial transaction models, there's often lots of interest in attackers trying to fool systems for those kinds of deployments. Lots of security applications also are worried about these kinds of impacts, but increasingly even benign applications. So applications, for instance, in resource allocation, say government wants to make a new program that makes decisions about allocating funds to certain parts of its citizens. There are often now worries about new ways that third parties that could be bad actors, in the sense of they try to exploit this algorithmic system to get different allocations than what would have been desired by whoever is designing the system. Other examples in vision include real-world attacks. So people have shown, for instance, that if I look at self-driving cars and I look at their image recognition technology that tries to tell, I'm showing on the bottom, one of the ways that self-driving cars work include having cameras that tell what's around. So in particular, they try to read street signs. And so you can imagine, and people have shown, that there are ways to change a street sign image. So in the real world, you might add some stickers to the stop sign. And the impact that you have is that instead of being read as a stop sign, this gets read as a 45 speed limit sign. And so for the human, this looks the same. The human driver, human expert cannot tell a difference. This just looks like maybe a sign that has some discoloration on it. But to the model, this looks completely different. And so there's a lot of worry in these kinds of adversarial security gaps in systems, and lots of work trying to engage in how to mitigate and fix them. And so this shows up in a variety of different ways. So all the way from distribution shift. There's lots of work in using various kinds of new tools to mitigate shift, including new kinds of data sourcing. So can I get data from the target environment? And increasingly the use of new kinds of ML and AI models. So things like causal inference are shown to be useful for mitigating some of the distribution shift issues. Sometimes personalization can be a solution. So instead of trying to build a single system that works across a large population and across time, build systems personalized to the individual user. And so you're not dealing with distribution shift of the style of differences across different users in different contexts, because your model is personalized to that user context. Lots of approaches here also use traditional security approaches. So things like guardrails to control data and access. Increasingly, there's work on AI guardrails. So these are algorithmic systems that are built to protect infiltration in AI systems. So also called guardrails also have a similar function, but these are, I guess, using modern tooling and approaches. And I've done work in some of these directions. And then they're also learning ways that you can improve the learning process to make it more robust. So people have shown, for instance, the leading way in particular of trying to get, for instance, large language models to improve, to jailbreak attacks and things like that, is to use various kinds of adversarial training. So you give the model examples of what bad actors might do, and then you try to make sure the model does the right thing in those instances. And so this adversarial training can sometimes be effective for mitigating security issues. Another set of issues are privacy issues. So classically in computing systems, the code for your computing system and the data for your computing system are two completely different things. So your code and your data don't mix. And so when you're thinking about privacy, you think about generally data privacy. And so you just think about protecting the data source that's tied to your whatever model or whatever computing system that you're building. With AI systems, the code and the data are very strongly mixed with each other, because the weights of your model are an encoding of the data that the model was trained on. And so you can't separate the code, the final sort of algorithmic system, from the data source, which means that if you're worried about privacy, your privacy gap now includes protecting the model itself, not only in the past protecting separately just the data, and you can think about the code as sort of, a separate issue. Now these things are very tightly coupled and mixed. And so a lot of the work in privacy and AI systems tries to ask about what are the vulnerabilities and what is the ability of attackers to infiltrate an AI model and then leak information about individuals from them. So there's a bunch of work. I'm not going into detail here, just giving high level. But there's a bunch of technical work and also societal and classic work to try to mitigate some of the issues with privacy. So one of the approaches, maybe the most popular set of approaches, are tied to what is known as differential privacy. So this is ways of changing the nature of the data or the model such that it's harder for an attacker to tell any information about individual samples. I'd say this is the leading approach for thinking about technical privacy issues. It does have meaningful gaps in that, in general, you lose performance when you try to implement differential privacy. So some of the leading edge in this work is in trying to make the trade-off less severe. So what can I do such that I can improve the privacy of the system, but not make the performance, much, much worse than it would have been without this kind of intervention? Often personalized models can play a big role here as well. So I talked about this in the context of security. Often personalized models can also be helpful for privacy, because if I'm not removing data from an individual or sort of organization, then I don't need to worry as directly for the ways that I'm worried about privacy attacks can be narrowed, because there's no explicit data leakage, and I can control model access so that I don't have information leakage through the model as directly. Also, as mentioned, there's lots of work in traditional security approaches, things like guardrails, increasingly modern approaches to guardrails. So can I, for instance, build a guardrail system that makes it harder for an attacker to tell a model to release individual information that violates privacy issues? And so it turns out that there are now modern ways to think about guardrail systems. So we built some of this in my group and also in other work corporations I've been involved in. So can we build algorithmic systems that improve protection tied to privacy? Okay, other directions of trustworthiness include algorithmic fairness. So I find algorithmic fairness an intriguing but challenging topic. But the reason we care about fairness are one of the framings that I find most useful is that we worry about the harms of algorithms when deployed at scale and affecting hundreds, thousands, millions, billions of people. And so some of the harms that we worry about include unfair allocation of opportunities, resources, or information, different quality of service for different people tied to whatever, say, demographics or other potential sources of discrimination. Stereotype reinforcement, so existing societal stereotypes that can be reinforced by the way these AI systems work. Denigrating or derogatory behavior, so models leading to what is often called toxic behavior to individuals or groups, or different kinds of over or underrepresentation of people. So acting, for instance, that different subgroups or different countries or different societies don't exist. And so some of these are some of the harms that worry algorithmic builders the most. And so some of what we try to intervene on in improving algorithmic systems. So one example that's salient for me is some of the work I mentioned, alluded to at the beginning, on potential race issues in many of the modern large language models. So I'm showing some examples here. They looked at, on the bottom, you can see a variety of different models that they interrogated. On the left, you can see some of the questions that they asked the models. And here they're scoring whether the model got the question right or wrong. And so sort of how good was the model for answering this question? And these are all questions that are potentially tied to demographic or race variables. And I think what is most interesting to me here are instances where the model makes a mistake that's tied to historical injustice or historical discrimination in the healthcare system, but discrimination that has been fixed over time. So one example is this EGFR, which is a measure that clinicians use to understand kidney function. So this helps them tell whether your kidney is working correctly and so whether they need to intervene in treatment. And for a long time, this measure was calculated differently for Black people than other people because it was thought that there was a difference in kidney function across race. And science improved over time, and eventually it was found that this was not true. And so this algorithm, this is an algorithmic system, but this calculation was modified to remove this race accounting and sort of correct for this failure in a healthcare system. Yet when you ask many of the models, they use the old formula that has this race correction. So somehow over time, even though the world has fixed itself, if you like, so it's corrected this issue, the systems are still using the old formula that doesn't have this correction built in, even though they've been deployed sort of much later than when the system was built. So to me, this is an example of this sort of distribution shift or data shift issue. The data has moved meaningfully over time. In this case, society has done the right thing, right? They've fixed the historical discrimination gap. Yet the models are still using the old data. And this is leading to incorrect inferences that you can imagine then, if deployed, will lead people to use the incorrect old formula when they should be using the new formula that corrects for this issue. So issues like this are often what worry individuals and societies when deploying AI systems. So as mentioned, often we can trace issues of fairness to issues of the data that the model was trained on. And so often the most obvious intervention and the most useful intervention is to fix the data before you train on it. So things like balancing the data across different groups, things like looking for spuriousness tied to stereotypes that might be in your data and making sure that you balance that out or remove those kinds of issues in your data sourcing. Those can have a big impact in what the system does once it's trained. But in some systems, they're too large, or data interventions don't seem feasible. And so in those cases, there is a bunch of technical work that has come up. I've worked on some of this and many others, perhaps some of you in the room, looking at various kinds of interventions in algorithmic systems to mitigate fairness issues. And so there are now many algorithms that can improve some of the fairness gaps, though most often data is the culprit, and you should actually just fix the data. And here, I think there's been the most embrace of this, some of what I alluded to at the beginning of the socio-technical aspect of trustworthiness. The fact that trustworthiness is a technical problem, but has important societal impacts. And so society should be part of the conversation in framing and implementing mitigations to trustworthiness issues. I'd say along the spectrum of different aspects of trustworthiness, fairness is probably the one that is most mature with respect to thinking through societal interventions in algorithmic systems. Okay, other aspects of trustworthiness include how well we understand the AI systems themselves. So often these are thought of in terms of transparency. So can I look into a model and get some sense of why it's given certain kinds of predictions? You can imagine, particularly for experts, this is a way to build trust in algorithmic system. And so there are lots of ways of engaging in this question. I'll mention here that increasingly there's an interest in what is sometimes called mechanistic interpretability. These are, you can think about this as ways of trying to interpret models based on the behavior of specific neurons or specific nodes within the model. The main difference from some of the earlier interpretation work is most interpretation work tries to find representations of the model or of the data as a way to build understanding. And representations meaning I take my model and I find some low dimensional embedding of the features, and this is a way that I can query or understand what's going on with the model. Now there's increasingly an interest in trying to find specific nodes within, say, a deep neural network, and then trying to interpret the behavior of a specific node as being the node that, say, decides a certain property of the model, and this being a way to engage with transparency or interpretability in AI models. More broadly, there's an interest in understanding transparency just broadly around the AI ecosystem. So I'm showing here work from colleagues that have tried to do this work on the taxonomy of who creates the data, who curates the data, what does the data curation look like, what data is used for training. So understanding the life cycle of data within large AI systems. And so they've done this as a taxonomy across lots of different models from lots of different potential providers. This goes all the way to things like Llama from Meta, which is these large language models, to scientific efforts. So things like Big Science did some work trying to build a open source language model called Blooms a while ago. And so they looked at their notions of transparency for that kind of work, all the way to more modern systems from Stable Diffusion, Inflection, some work from Amazon, various other companies. And they looked at aspects of data, labor, compute, various aspects of transparency with respect to models, architectures, mitigations that were built, distribution, usage, feedback, and tried to score the systems across lots of different examples. So if you haven't seen this and you're interested in understanding something about what is known about the way various systems are built, this is a good resource for trying to understand some of these aspects, the foundation models, transparency index. It also tried to score overall transparency of existing systems. So, Llama is generally considered the most transparent of the large AI systems, and competitively transparent compared to things like Blooms, which are academic efforts. OpenAI scores highly here, I think, because they always present the model cards. They say something about the architecture, though they rarely talk through the details. Again, I think this is interesting. This says something about understanding what goes into building models. for many stakeholders, this is how one builds trust. So understanding the aspects of model building is how one understands potential ways that the model might behave and then potential ways the model might fail. And so transparency is, again, one of those issues that increasingly is becoming salient. And thinking through at what stage we're looking at the model building process and to what extent is the model transparent, all the way from data to the actual architecture built. And what is the role of humans and various kinds of stakeholders in understanding and digesting transparency, and what is the impact of this on trust and trustworthiness? Increasingly, modern AI systems are built not just with data that's existing from people, but actually are increasingly built by active participation of humans and feedback to the system. So I'm showing here an example from some of the this is from OpenAI and their work on large language models. But this is a good example, I think, of how many of the modern generative AI systems end up being fine-tuned. So they're built in the way that I described earlier, generally using some kind of completion unsupervised learning. Once they're built, they often have some kind of fine-tuning process that engages directly with people telling the models where they're making good and bad decisions. And this is considered important both for fine-tuning to human preferences, so both capturing like what would a human in different contexts want a model to do, but also increasingly there's an argument that this is a way to capture human values. So what is important to society in building and deploying and in the implementation of AI models? And so it is thought that constructing models and then collecting demonstrations and preferences from people is a way to engage with this question. And so the way this works is, you take a trained model, you generate examples from the model, you ask people to rank examples. Often this is a binary choice. Do I like A versus B? I give you two examples of a model's response. Which one do I like better? And the more sophisticated version of this is instead of two, I give you some larger set, 3 or 4 examples. Can you rank them? Which is, do I like 1 better than 2, better than 3, better than 4? And so this is an example of what a ranking might look like. And then once this is done, then you do some work behind the scenes, often using reinforcement learning, but then there are other methods that people have developed more recently as ways to improve the model to align with the expressed preferences. And so this engages very strongly with humans playing a big role, individual preferences playing a big role in deploying AI systems. And we care about this for many reasons. Often this is a good mechanism for signals of correctness that we don't have good data or good loss functions to define. So an example, what does it mean to be funny? There's no equation that defines funniness, but you can get examples and ask people to tell you, do you think a particular response is funny or less funny? Increasingly, this is, again, as mentioned, thought of as a good way to implement various kinds of trustworthiness mitigation. So is the model helpful? Is the model fair? Is the model safe? All these things are often tuned using this kind of preference feedback from people. It is often useful when we think we know how to evaluate a certain behavior. So say humans can give a signal about behavior of a model, but we don't have a good way to build models of what ideal behavior is. So here again, we're relying on people to give us feedback as opposed to the models or some other algorithmic platform to tell us what correctness is. And then in many cases, just a useful way, it's turned out to be a good way to fix model mistakes. So, we may have good normative knowledge of good and bad behavior from a model, but it's somehow hard to encode in the training signal. And so we just use humans as a proxy, and this helps us improve the systems. Now, while this has been enormously successful as a mechanism for building systems, some of you might know that when we study the final models, we sometimes find big demographic aligned preferences in what the models end up picking up on. So I'm showing some results from a paper last year from some colleagues here who looked at one of the leading AI models and then asked it to take a survey. So an opinion survey that is typically given to people to get their opinions across lots of issues. So questions of education preferences, questions about the future, questions about the healthcare system, immigration questions. So a broad range of often contentious and difficult questions. And so they asked, these are surveys typically given to people to get a pulse of people's opinions in many countries. Here, they asked the models to complete these responses. So here, instead of having people give their opinions, they're asking the models to give quote unquote opinions. And what they find is that the models do have a particular quote unquote point of view, meaning they align strongly with certain kinds of demographics. And when they looked at the responses of the models, what they found was that the models seem very close to preferences that you might find in where I am right now. So, in Western US, Bay Area, California. So in some ways, this is not surprising because the people building the models mostly are around here. And you can imagine that when they're refining the models, what they think of as correct responses from the models is very tied to their cultural preferences and their cultural values. And so very easily this seeps into what signal is given to the models and what the models train to be better at. Also, this shows up from the data that they're trained on. So internet data also generally reflects preferences that are close to Western US preferences. And so this shows up in the model, which is maybe fine if it's only deployed in the US, but I think increasingly worrying when models are deployed across the world where values differ quite significantly. But yet the models are not necessarily reflecting where the models, sort of the preferences of the deployment context. I think increasingly with this mechanism, there are also hard questions that the field has to answer on ethical issues tied to data labeling. I think this is a very hard issue. I think it shows up in lots of different directions. I want to be careful about strong normative claims here, but there is the observation that often these large, powerful companies choose to outsource a lot of the final labeling work across the world in places where it's cheaper for them, potentially economically useful for the workers that are doing this work. But there have been reports that some of the workers doing this work get exposed to quite challenging experiences. So sometimes have to complete prompts that have potential psychological harms. And we don't have good mechanisms yet for both protecting people that are engaging in this work, yet still being able to collect the signal that is considered quite important for building many of the modern AI systems. So this is an issue I think the field increasingly should be grappling with, and early work, but I think something that we can make progress on in ways that are hopefully societally beneficial to all the stakeholders involved. So both providing economic opportunity for the workers that want to engage in this, but also mitigating harms that they might suffer in having to do this kind of work. So I don't think we have good answers for many of these questions yet, but I will say this broad question of trying to understand and mitigate preferences across stakeholders is one that I've been interested in. So I've done a variety of work that I just mentioned very, very briefly on this question of how do we interact with people in order to get their preferences, and hopefully in a way that can happen efficiently and minimize potential harm to various kinds of stakeholders. So feel free to look at some other references offline if you're interested in some other work that we've been doing trying to engage with this question. So to summarize the bulk of the conversation today, I want to talk again about there are two aspects of this question of building trust in AI systems. There's the trust part, which is really about the people, and then there's the trustworthiness part, which is about the algorithmic system. These are complex, multidimensional topics. They have lots of components, all the way from safety and security to accountability, fairness, and ethics. And increasingly, the field is trying to grapple with what we can do on the technological side to ensure that these systems have better properties, such that we can integrate with the social and individual side, such that we have well-calibrated trust in AI systems. Often these are hard to socio-technical problems, and increasingly there's policy interest in engaging in some of these questions. For the next maybe 10, 15 minutes, I want to talk briefly about evaluation and benchmarks. To give a framing of some of the other side of this, benchmarks is some of the most interesting emerging avenues of trying to understand systems. And so as the systems have grown in size and in usage, they've increasingly been applied to various kinds of tasks. And so the question of what it means to trust an AI system, as I alluded to, has become both more interesting and important, but also we're essentially trying to put more effort into trying to specify and ground this question. And so one model that's interesting is car safety ratings that some of the field have been trying to engage in. This is the question of, can we use some of what we've learned from, for instance, safety ratings from the way cars are tested as a way to frame what it might mean to build AI systems that are tested and can be considered trustworthy. And so if you buy this analogy, benchmarks and evaluation have come up as one of the maybe more interesting approaches to engage in this question. So I'm showing some examples here from a recent study, focusing particularly on the benchmarks that try to handle fairness and bias kinds of questions. So benchmarks, again, are this combination typically of some data source, some notion of metric, and then some norm about what it is we're measuring and what we hope to get out of the evaluation process. And there are lots of these benchmarks out there in modern AI. I think one of the more successful ones is the holistic evaluation of language models out of some colleagues at Stanford, so Percival Yang and co. And so what they do is provide a framework that takes lots of different models across scenarios and comes up with a systematic mechanism for evaluating them. So this looks like various kinds of scenarios. Are you interested in question answering? In what setting, say in Wikipedia for web users in 2018 in English. And so you can have all these combinations of task, who, what, when, and what language, and also different combinations of kinds of perturbations and various kinds of metrics. And all these combinations allow you to have a broad understanding of the capability of models across lots of different contexts. So you can ask questions tied to natural question answering, various kinds of fairness attuned responses from models. You can ask metrics related to fairness and bias, toxicity, various kinds of calibration questions. It has this usefulness of standardization, so it allows for broad coverage across lots of different settings. The robustness one is kind of interesting. So here they show examples to models and then change a few words and check if the model prediction remains the same. So this captures or catches some of the issues in AI models where small changes might actually lead to very different responses. You can also do this tied to fairness questions. So you can, for instance, change the gender of a particular phrase and see whether the model changes the response. This is interesting for bias questions. So you can ask, does the model tend to always use male or his and he when it's talking about mathematicians, but use something else when it's talking about different kinds of job roles? Excuse me. And so these are the kinds of questions or ways you can interrogate model responses to get a handle on various kinds of demographic biases, for instance. You can also score the models on toxicity. So is it, for instance, showing responses that show very specific kinds of demographic and context biases. And people have done work engaging with how to improve the systems, these evaluation processes when we're using this in human AI systems. So specifically here, looking at how automated metrics might still have gaps to real world use cases and what evaluation processes can be developed to try to mitigate some of these issues. Last year, we did some work specifically interested in the trustworthiness aspects of evaluating models. So we looked at a lot of what I've shared with you already today. So questions of robustness, questions of out of distribution and adversarial robustness, questions of fairness, questions of privacy, showing where the models performed well and where there are gaps in the system. This is a framework that we ended up releasing, so open source that people can build on and deploy, that allows model developers and people who are interested in deploying, particularly language models, to have evaluation of the trustworthiness aspects of the AI systems. Beyond the trustworthiness questions, there have been lots of interest in predictability of model behavior. So this question of what does a model end up being good at when I make it very big? And so this has been one of the driving evaluation and benchmark questions in the field. Another work we did last year was trying to understand when we see big improvements in these models, Are they best explained by the models getting better in an unexpected way? Or to what extent is our measurement process being reflected in the way that we evaluate model performance? And so very briefly, what we did is that we showed that if I change the way I measure models, for instance, going from standard evaluation metrics to various kinds of linear score metrics or continuous score metrics, that you can change an observation of something called emergence in language models, which is this phenomenon of what it seemed like models got much better very quickly as I scaled up performance in a way that was unpredictable, which is worrying for people who are worried about capabilities of models and potential safety concerns. And so this led us to, I think, a set of framework that we're now currently developing to help guide if you considerations for people who are trying to build AI system evaluations, such that those evaluations actually answer the questions that they want. So one way to frame this is that there's a lot of new engineering questions and AI technical questions that we think will play a big role in governance and policy. And we think that framing this as measurement science is a sort of productive way to try to engage in improving how we build measurement processes for AI systems. So this has led to, I think, some useful knowledge improvement on what it means to build good evaluations and benchmarks, including questions of making sure that it's clear how these benchmarks are run. Is it clear what the baselines are? So are we comparing this to other models? Are we comparing it to what humans might do? What are warning signs if an evaluation process might be broken, such that we may need to update it to make sure it's fixed? And so if we think evaluations are one of the most productive ways of engaging in understanding the trustworthiness properties of AI systems, then increasingly we're understanding what it is we need to build to make sure that we can evaluate properly when we build and scale these systems. Okay, so I want to conclude. So thank you for your attention today. We talked through sort of tutorial discussion of AI trustworthiness. As you might see, trustworthiness is a complicated topic with many open problems. But I think lots of work already trying to engage with this, but increasingly clear that we need more effort to close many of the gaps. Many of the gaps tied to what the role of users are, what the role of different stakeholders are, how we think about selecting metrics, what the impacts are downstream of AI models, and how do we measure them. I think society ends up playing a big role in what it means to trust and build trustworthy systems. And there's lots of work in standardization and transparency that we hope will help mitigate many of these issues in trust and trustworthiness. So today, I think we had this hopefully useful, broad discussion of many aspects of trustworthy AI systems. I, in the first part, introduced the landscape, talked through some of the motivation and some of the political, social, and industrial aspects of this. And I briefly talked through evaluations and benchmarks as a way to frame mitigation of these kinds of issues. Maybe I'll leave by saying that I think as a goal for particularly folks who are thinking of building AI systems, that our goal should be to deploy AI systems that support human goals, but is constrained by our human values. And a lot of answering this question ties to questions of building trust and trustworthiness in AI systems. And so I'll end here, and I'm happy to answer questions for the next few minutes. Thank you for your attention.